So a listen node's been set up a node-red that monitors the home network for every time a locomotive is detected within range of a RFID reader. The next thing we'll look at is extracting the data we want to use for the model railway project. Start by setting up 3 separate tabs in node-red. The first tab can be for test, the second for config, and the third for track. To organize the testing, configuration, and train tracking logic. As the listen node is finished testing, it can be moved to the config tab, where it can continue actively listening for RFID events. Right, time to move the reader under the baseboard and check its read range. Slimline RFID stickers are better suited to attaching to model trains and easier to handle than RFID keyring fobs. So one of these stickers can be attached to the front of the Intercity 125. These 12-volt readers have a good read range. RFID data pushed to the home network appears in the debug panel, and this data is being logged to the debug panel by the listen node running in the config flow tab. The data that's most useful is the controller's serial number, the RFID tag number, and the time that the RFID tag number was detected. It looks like there's a slight issue with the time, where the controller drops the current time each time it's turned off and back on again. Possibly it's because controllers are intended to run 24/7. So to fix this issue, we'll add a function that sets the current time each time the node-red application starts. The UHP examples will give us some JSON code that can be injected into a set time node. By ticking the Inject Once box in the Inject node, the set time activity will run automatically each time you start node-red. As the set time function is working okay, it can be moved out of the testing flow into the config flow, where it will ensure the current time is set each time node-red starts. Great, we're ready to start working on the layout design. First, we'll need to import node-red dashboard. So we'll use Manage Palette to install the node-red dashboard, and then after that we'll also grab the node-red LED package. The link in and link out nodes are useful ways to move data between the flow tabs. Using a switch node lets us extract the RFID tag number from the list of attributes contained in the JSON object, which we can see in the debug panel. To extract the RFID tag number, follow the path to card down the JSON object tree. Adding the attributes loco for the train name and color to identify the train visually on the track layout, and also setting the attribute message.payload to true, which is something we'll look at shortly. Start by opening the dashboard section and dragging in 4 or 5 LED nodes, which will be used to simulate tracks on the display. Open the dashboard from the drop-down arrow in the top right corner. Open up First LED and click the plus sign to set up a new dashboard group. We'll set the shape of the LED to a square to make it look more like a track. Great, the testing and configuration is finished. We're ready to add a piece of track to the layout designer. Next, click the layout button and we'll set the position of tracks in the display. And leave the space for the LED that will turn a different color depending on the locomotive that's been detected by the RFID readers. Okay, looks good. Now drag in a template node from the dashboard section. ChatGPT has helped generate some code that can be copied into the template node that lets the LED change color based on the input attribute message.color and the input boolean message.payload. Let the RFID reader detect a new tag event, and the stretch of track that has detected the Intercity 125 has turned orange. The attribute set up for message.loco can be used in a similar way by dragging in a text node. When the Intercity 125 travels over a piece of track that has a RFID detector underneath it, its location is updated on the display, and the name of the locomotive detected is also shown.